Good morning, ladies and gentlemen. Thank you for inviting us here today to give this presentation regarding the use of nitrogen in sustainable agriculture. By offering this substance flow analysis, we hope that we will be able to offer some real solutions to tackling this issue. This substance flow analysis illustrates the flows of nitrogen compounds through the region, which just so happens to be also called nitrogen. As you can see in this flowchart, these compounds enter the system as either fertilizer, fodder, or food. We have been working together with the local government of the region in addressing the environmental problems that have arisen from the current model. There are two underlying environmental problems that need to be addressed. They are 1. The acidification of soils through deposition of ammonia. 2. The contamination of groundwater through leaching from agricultural soils. The first problem, ammonia depositation, finds its origin in the waste from animal production facilities. The installation of filters on stables can reduce the deposition rate by almost 90%. Although this requires filters that are 95% efficient, we believe this solution is easy and relatively cheap to implement. The second problem of the leaching nitrate in the groundwater provides a more difficult challenge. A portion of the fertilizer and manure that is applied to crops dissolves in water and leaches into the groundwater. Around 65% of the manure leaches away. Manure and other animal waste are the largest contributors to groundwater contamination. Thus, animal production is a key process in solving this problem. We have analyzed the effects of various scenarios and their environmental consequences. You could reduce the use of fertilizer, but this leads to less crop and grass production. As a result, it is necessary to import more food to supply the inhabitants. This is simply removing the problem to another region. The animal production could be reduced in two ways. Firstly, you could reduce the import of fodder. This will be compensated by more local fodder production, requiring more fertilizer. Overall, the environmental pressure remains the same. Secondly, the amount of animal products consumed by society could be restricted. As you see in the picture in the top right corner, around 13 pounds of grain is needed to create 1 pound of meat. Thus, less animal production and consumption reduces the demand for crops, even though crop consumption by humans increases. In this scenario, the amount of manure is reduced, decreasing the amount of leached nitrate. As a side effect, less fertilizer is required. Based on our findings, we make the following recommendations. Firstly, we do not recommend importing food as a viable solution. This will simply result in shifting the problem elsewhere and will result in even further food dependency. Secondly, we recommend installing filters on animal stables and reducing the amount of animal consumption to less than 70% of all food consumption. This recommendation alone will make the objectives set by you achievable. The government can also decide to adjust the objectives regarding the reduction of leaching of nitrates. By making a reduction of leaching by 50% instead of 75%, a reduction of 30% of animal consumption would be necessary. By adopting this solution, the beautiful region of nitrogen will become self-sustaining. We classify self-sustaining as consuming less than 10% of imported food. Furthermore, we recommend attempting to influence the consumption habits of the people in the region. The government could also stimulate through subsidies the promotion of white meat rather than red meat. Red meat consumes more nitrogen and creates more waste than white meat. You can also make the nitrogen uptake from manure more efficient, either by more precise placement of the manure on crop and grass fields, or by the use of genetically modified crops. To conclude, the first solution may prove to be easier to implement. However, it will require new development in farming equipment, as well as changes in farming operations. The second solution, however, may prove slightly more difficult, resulting in more time and money needed to be invested. In general, more efficiency in the food production chain leads to less pollution. We hope that we may have offered some viable solutions to this problem, and we would love to hear your feedback. Thank you very much for your attention.